Hello and welcome to this video tutorial on carboxylic acids and esters. So far in topic 3.3 hydrocarbons, we've gone through the hydrocarbon skeletons, naming them and identifying functional groups. These are include your alkenes, alkynes, and your alcohols. And we know that these functional groups are reactive sites. Now in this tutorial, as mentioned, we'll be going through carboxylic acids and esters and identifying the structural components of these. Then we'll go into the naming of carboxylic acids, and briefly we'll talk about esterification, which is the process in which we use to derive esters. Carboxylic acids, they are a very weak acid. They contain a carbonyl group and a hydroxyl group, what this means is we have a carbon right here. It contains a carbonyl group and a hydroxyl group right here. This whole structure is called your carboxyl group. The R means that it is the rest of the carbon chain. I guess you could say it is an alkyl group. So it could be a CH3, CH2, CH2, CH3, and so on. It is just the rest of your hydrocarbon chain. Carboxylic acids have the suffix oic acid, ethanoic acid, propanoic acid. These are examples of carboxylic acids. Again, here's the structural component of a carboxylic acid. We have our carbonyl group, and on the same carbon we have a hydroxyl group. This whole thing is classified as your carboxyl group, also your carboxylic acid functional group. They are always found on your terminal carbon. What this means is you'll always see your carboxyl group on the end of every single, at the end of your hydrocarbon chain. If we have examples of carboxylic acids, we have methanoic, ethanoic, propanoic, and butanoic. You can see that all of the carboxyl groups are found on the end carbon. When you're going to name them, the first thing in any hydrocarbon is to identify your functional group. As we are naming carboxylic acids, we know that we'll have a carboxyl group, which is at the end carbon, your terminal carbon, which is right here. So on that carbon we have a carbonyl and a hydroxyl, therefore this whole thing is a carboxyl group. Now we know that it is a carboxylic acid, it will have the suffix oic acid. The next thing is to identify your longest carbon chain, starting from the carbon that is attached to your to these things right here. So we have carbon 1, 2, 3, 4. 4 carbons means that it will be a butanoic acid. This is very simple, much like these ones are quite simple too. Methanoic acid, because we have one carbon. Ethanoic, 2 carbons. Propanoic, 3 carbons. Butanoic, 4 carbons. Now what about if we want to name them when they have their structural, when they have their substituents, their little methyl groups added on? So I would begin with identifying any of your functional groups. Right now, as we are doing carboxylic acids, you can see that we have a carboxyl group right there. That is our functional group. That means when we go to name this structure, it will end in oic acid. The next thing is to locate your longest carbon chain. Now when you are locating them, you can give them numbers. You start from the carbon that is in between. That is where your carboxyl group is. So that's 1 carbon right there. So we'll start on that one. So we have 1 carbon, 2 carbon, 3 carbon, 4, and 5. The longest carbon chain is 5. Therefore, this will be a pentanoic acid. Now we can't stop there. We have substituents, which are our methyl groups. I will circle them in red. We have a methyl group on carbon 2 right here, and another methyl group on the same carbon. When you go to name this, I would say that we have a 2,2 dimethyl, because we have 2 methyls on this second carbon, dimethyl 1, 2, 3, 4, 5 pentanoic acid. Here we have a range of our substituents, and first you will need to identify the functional groups present, and of course we have a carboxyl group right there. making this structural name end in oic acid. Now your next thing you want to do is identify or locate the longest carbon chain. Starting from the carbon at your carboxyl group, we have carbon 1, 2, 3, 4, 5, 6, and go back. As we have 6 carbons, we know that this will be a hexane oic acid. Now identify your substituents. We can do that in red. We have our ethyl group right there on carbon 3, and we have a methyl group on carbon 2. This means when we name it, it will be 3-ethyl 2-methyl hexanoic acid. Remember to put your ethyl before your methyl, as it is in alphabetical order. 2, 3, 4, 6. Yes, just checking it's correct. When it comes time to naming hydrocarbons, the first thing you want to do is see how long your longest carbon chain is. As we have a butanoic acid, butane meaning methylpropute, we have 4 carbon chains. So we have 1, 2, 3, 4. And I did not mean to say 4 carbon chains, we have 4 carbons in the longest chain. So 1, 2, 3, 4, that's butane, and oic acid means we have a carboxyl group there. So on the final carbon we have a double bond to our oxygen right there, and as well as a hydroxyl group right here. Now it is butanoic acid. And on the second carbon we have a methyl group. When you're counting them, be sure to count them from the carbon that is from your at your carboxyl group. So we have carbon 1, 2. This is where our methyl group is right here. It's nice and pretty. This one is a little bit more complex. It has quite a few more substituents. First thing, again, start off with your longest carbon chain. We have heptanoic acid, hepta meaning 7. So we'll have 1, 2, 3, 4, 5, 6, 7. Oic acid meaning we'll have a carboxyl group, which will be a final carbon double bonded to an oxygen, and a hydroxyl group right here. That whole thing is your carboxyl group. Now we have 4 methyl, so that means on the 4th carbon we have a methyl group. 1, 2, 3, 4 methyl group. You can just go straight up like that. And on carbon number 2, as well, carbon number 2, we have an ethyl. We have 2 ethyl groups. So on 1, 2, on carbon 2, we have 2 ethyl. And just draw them like this. These lines represent for every point and every edge we have right here we'll have a CH2 and a CH3. Again, a CH2, a CH3. I apologize with my poor, with the skeletal structure, because these nifty tools won't let me draw pretty pictures. Next off, we are talking about esters. Now, in this whole introduction to esters, it will be very brief. We'll just identify the functional group, what it looks like, and how we make them. We will not go into naming them or anything, just very simple. So esters, the structural formula looks like this. So we have, on one carbon, we have a carbonyl group and a single bonded oxygen to the R groups, meaning the rest of the carbon chain. And this one, likewise, the rest of the carbon chain. This means that they are found in the middle of your structures. So here we have ester structures. This is our whole hydrocarbon right there. Esters, which your ester functional group in the middle, your double bond to oxygen, single bond to your hydrogen, and the rest of your carbon chain, they are always found in the middle. Again, this ester is found in the middle, and this ester is found in the middle, or between carbon chains. They're not necessarily in the middle. Esters, they contain a carbonyl and an oxygen that is attached to the rest of the carbon chain, which is a carbon OO and then rest of the chain alkyl group. The R groups are your alkyl carbon chains. You already know that. Esters have a suffix -oate. So we can have ethyl ethanoate, propyl methanoate. They are esters. Now, we can form esters through this process called esterification. Quite simply, we can react carboxylic acid, which we know about, and alcohol, which we also know about, mix them together, warm conditions, acidic conditions, and we can form esters and water. Now, we have propanoic acid. Right here we have a carboxylic acid. We know this because there is our carboxyl group right there. And our ethanol, because we have a hydroxyl group right there. We have a carboxylic acid and an alcohol. We react them together and we form an ester link, which is in the middle, where we make an ester. Notice how we form water. Now, where does these molecules come from? We have propanoic acid, which I guess you could say we cleave off the hydroxyl with the OH group, and with the alcohol we get rid of the hydrogen group, we mush them together and we form our water. Now those that fell off, we get rid of those, and that leaves this chain and this chain somewhat open, and they attach to each other, and that's how we form our ester link. It is probably a little bit more complex than this. However, all you need to know is that the OH off of the carboxylic acid donates along with the hydrogen from your alcohol to form your water. And this concludes the rest of my very long video. I hope you enjoyed it.